back again. This is part 3 of UNIX shell scripting and utilities, week 11. More awk, whether you want it or not. So let's get out of cheese and come back to this. We were talking about variables and coercing a variable into being something other than what you might think it is. We can create a variable, 38 in this case, which is forced to being considered a string by putting quotes around it. If it just sees a number, it considers that to be a digit. So let's move forward here. So let's say I want to do this. In this case, the NR field can be used to select which records to process. So if the number of records is greater than 1, I'll print the whole record for some file. Now, why would I want to do that? Well, here's the fun thing. Remember, if I do this, AUX, and pipe that to more, what's record 1? Well, that's this. So what if I do this? Awk. I'm going to put the number of record greater than 1, right? NR greater than 1, right? Okay. Now what do I need to do? I need to give it some action. So I'm going to get the curly braces. I'm going to use print in this case. I'm going to do $2, comma, $3, comma, 1, 2, 3, 4, $4, comma, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, $10, and $11. Now, what am I doing here? Well, actually, I want to do this. PS AUX, pipe that to awk, and I'm going to pipe that to more. Ah, I can't do a PA command, can I? But it worked. It did exactly what you expected it to do. Okay, let's try this. That's interesting. There's all the process IDs. Notice 1, 2, 3, 5, 7, 8, 9, 10. There are the IDs. Cool. That worked kind of neat. So here's another one. If record equals 2, then print the first and the second fields in that record. So the RS and FS, let me get out of this. Let's see if we've got this name underbar address. Yep, that exists. So let's do this. The RS and FS can be used to handle vertically oriented files. Ooh. So what am I doing here? Well, what am I doing? First, I'm setting a record separator and a file separator. In name address. So, let me do this. More name underbar address. Notice how this lays out. Bob Jones is the first record. Actually, it lays out where I have Bob Jones and Comiskey Way, name and address, on 2 lines. Normally a line's a record. What have I done here? I said a record separator is 2 new lines. So if I VI name underbar address and I do set list, what do I find? Single new line is a field separator. 2 new lines is a record separator. Is that really what I did here? Yes, record separator equals 2 new lines. A field separator equals a single new line. and then print $1 and $2. So it took Bob Jones and spit this record out in a horizontal format as opposed to the vertical format that it was in the file. So it took Bob Jones, created a record, and the default output field separator is space. Created the space. The default output record separator is a new line. Put a new line. Found Sheila. Put Sheila in there. Found Tanya on Club Way. And put those two lines together. So it works. It does exactly what you expect it to do. Cool. Now, why did I mention that of all things? Because at some point in Project 5, you're going to be asked to change the orientation of the output from horizontal to vertical as opposed to vertical to horizontal. So, now, what did the begin do? Well, the begin said, I want to declare these before you do any processing of records. This is going to happen before you process the records, and it will help you understand the records when you get ready to process them. Cool. So, a value for a variable can be supplied from the command line. For example, this awk file contains a variable called city. So I want to print locations based on city supplied on the command line. And this is going to give me this $12 is equivalent to the city or the cities contained therein. I'm going to print a store ID, a store name, and address as city, state, and zip. So it will accept a command for city. So let me try this. What have I got in here? Do I have the DC area Starbucks file in there? Yes, I do. So what have I done? On the command line, I'm asking it to read this special awk file, and I'm going to set the city equal to Herndon, Virginia. Notice what I get. I get the store ID, Herndon. So what happens if I do this? What happens if I do Washington, right? Did exactly what I asked it to do. Cool. Okay. Moving forward, you're going to get a project in class that will look at grades. And there's, if I remember correctly, if we go back to the end here, let's see, there's grades, right? More grades. So there's a set of grades. Now the fun thing is you're going to cat the file grades first, and we just did that. Create an awk file that will place the name and % grade on each single line for each student. There are 300 possible points. The numbers represent the points each student achieved for a graded segment. So your output should be 79.7, whatever. You can work on that. We'll get to that later. So assignment operators, variable expressions, string can be used. So a string can also use variable expression, the operators, the arithmetic, increment, decrement operators, the x++ to be equivalent to x plus 1, the x dash dash equal x minus 1, post and pre-increment. So if I do x++, that will implement, or that will increment after the action. A plus plus x does that before the action. So we'll take a look at this AOPRPO.txt file when we get into class. I'm not going to go through that now. So the begin pattern is followed by an action segment that's executed before awk processes any record. So in this case, I'm asking it to begin by printing years, accolades, name, and then putting some text underneath that. See the new line right here? This is the new line. And then put this stuff underneath. Okay. And what's the /T, the escape T? That's a tab. The end pattern, as the name implies, is executed after all the records have been processed. So end, print, there are FNR records. Cool. That'll tell you how many records were actually there in the file. Input redirection can be done. The getLine function can be used to read input from standard in, a pipe, or a file. So here's an example. At the end, date, getLine D, print, there are FNN records and D. In other words, run the date command. I can also read user input and assign it to a variable inside awk. Now you're going to get the thrill and privilege of using user input in your shell scripts. You can also use it in awk scripts, but that would be done using the getLine function. So anyhow, let me stop here. Awk is an interesting tool. It existed after SED, but before Perl and Python were available. Awk is a useful tool in Unix. It can do a lot of fun things. Are Perl and Python better? Well, Awk is a scripted language. Python and Perl are both scripted languages. C, compiled language. Would you be better off using Python and Perl for everything rather than Awk? Well, there are some people that would say that yes, you're better off using Python or Perl. And there was an interesting piece in Stack Overflow. So what are the differences between Perl, Python, Awk, and SED? So what's the main differences in the power of each language? Where to use it? When is it better? So I want to go down here to slots. He has a couple of interesting things to say. Not necessarily better. There are two unrelated things in the list: Perl, Python, Awk, and SED. Thing one, the simplistic text manipulation tool. SED, it has a fixed, relatively simple scope of work defined by the idea of reading and examining each line of a file. SED is not designed to be particularly readable. I don't know. It's never been a problem for me. It's designed to be very small and very efficient on very tiny Unix servers. Awk, it has a slightly less fixed, less simple scope of work. However, the main loop of an awk program is defined by the implicit reading of lines of a source file. Well, there's nothing entirely wrong with either of those statements. And the next statement, these are not complete programming languages. Well, that's true. You can, with some work, write fairly sophisticated programs in awk. It rapidly gets complicated and difficult to read. So, thing two, general purpose programming languages. Well, I'd have to scripting languages, Perl and Python. So then he comes out and he says, when to use them? Don't use SED. Well, actually, SED makes a lot of sense. SED makes some sense in using when you've got something you just need to throw up quickly. SED will allow you to spit out specific things from a file. It will allow you to change things. It's quick, it's easy, it's dirty. It can get things done in a hurry. Awk, he says never use awk. It reflects an earlier era of computing. Well, yeah, but you know what? You can do some things fairly quickly with awk. Awk is a fairly straightforward, easy to use language. Perl, any programming problem of any kind. If you like free-thinking syntax, there are many, many ways to do the same thing. Python, any programming problem of any kind. If you like fairly limited syntax where there are fewer choices, less subtlety, and perhaps more clarity. So, slot gets some pretty pointed, barbed replies for that. And I think in your careers you're going to find that you're going to run into people like slot. There are some folks who know everything. Just ask them. So, I particularly like this answer. In order of appearance, the languages are SED, awk, Perl, and Python. The SED program is a stream editor and is designed to apply the actions from a script to each line. It's a specified range of lines of the input file or files. It's based on ed. the Unix editor, and although it has conditionals and so on, it's hard to work with for complex tasks. You can work minor miracles with it, but at a cost to the hair on your head. However, it's probably the fastest of the programs when attempting tasks within its remit. In other words, within the the remit being what it was designed for. It has the least powerful regular expressions of the programs discussed, but it's adequate for many purposes. The awk program from Aho, Weinberger, and Kernighan is a tool originally for formatting reports. It can be thought of as a souped-up set. In more recent versions, those that are the GNU awk, GAWK, it's computationally complete. It uses an interesting idea. The program is based on patterns matched and actions taken when patterns match. The patterns are fairly powerful, extended regular expressions. The language for the actions is similar to C. One of the key features of awks is it splits the input lines into fields automatically. Perl was written as an awk and sed killer. Two of the programs provided with it are A to P, awk to Perl, and sed to Perl for converting awk and sed scripts into Perl. Perl is one of the earliest of the next generations of scripting languages. It has powerful integrated regular expression handling with a vastly more powerful language. It provides access to almost all system calls and has the extensibility of the CPAN modules. And one of Perl's mottos is TMTOWTDI. TMTOWTDI. There's more than one way to do it, and that is one of the all-time great things about Unix, is if you can do it, you can always find another way to do it. Python was written last, and probably in part a reaction to Perl. It has some interesting syntactic ideas. Indenting to indicate levels, no braces are equivalent. So if you're in that, if you're tired of dealing with braces or typing braces, maybe Python's what we need to learn. But it is more fundamentally an object-oriented language than Perl. But it's just as extensible as Perl. So, okay, when do I use them? Sed, when you need to do simple text transforms on a file. Awk, when you only need simple formatting and summarization or transformation of data. Perl, for almost any task, but especially when the task needs complex regular expressions. And then Python, for the same tasks that you could use Perl for. So it's one of these, what would you rather do, Perl or Python? Now, I'm going to say one thing that may cause some confusion, but I sincerely believe that you need to avoid complexity when simplicity will suffice. Use the simplest thing you can to make the problem or the needed piece work. Keep everything simple. Keep it simple. You can't go wrong with that mantra. One of the great things about Unix is that it allows you to take simple tools and build on those individual tools. When we get into the process of scripting, building scripts, take small blocks. Make sure the block does what it should do. It's blocks of script information, just a chunk of code. Make sure that does what you expect it to, and then pass that on to the next piece of it. Put those two pieces together so that they work the way you expect them to work. Now, here's another fun answer to that. So after mastering a few dozen languages, you get tired of people like the post below. Sed is the best tool for extremely simple command line pipelines. In the hands of a sed master, it's suitable for one-offs of arbitrary complexity, but it should not be used in production code except in very simple substitution pipelines. GAWK is by far the best choice for complex data reformatting when there is only a single input source and a single output. So we get to that. Perl or Python are far better than any version of awk are said when you have very complex input-output scenarios. The more complex the problem is, the better off you are using Python from a maintenance and readability standpoint. However, a good programmer can write readable code in any language, and a bad programmer can write unmaintainable junk in any language. So the choice of Perl or Python can safely be left to the preferences of the programmer if that programmer is skilled and clever. So there you have it. We're at the end of part 3 of week 11, Unix shell scripting and utilities, and this has been awk.